this lesson, you're going to learn how to determine how much quantity of inventory to order based on some different costs of ordering and holding inventory. But before we get to the idea of calculating how much you need to order, let's look at inventory from two different perspectives. And these two perspectives are dependent demand inventory and independent demand inventory. Now, what do we mean by dependent demand inventory? Dependent demand inventory basically means it's the inventory for the parts that you are going to make in-house. So here, for example, you see a recipe for making a certain kind of bread. Now, once you know how much quantity of bread you would like to make, the dependent demand inventory is going to be determined by the recipe. It tells you how many eggs are needed, how much salt is needed, how much flour is needed, how much water is needed. So it's going to be determined by the demand for that finished product. That's going to tell you how much of the dependent demand inventory you need to take care of. Another example you can think of is once you decide how many cars are going to get manufactured, you can look at the recipe, the bill of material that you have for making that car, and you can see what are the different parts that will be needed. To give a very basic idea, you're going to need 4 of the tires, 4 wheels for the main ones, and then 1 for the spare, and that's going to get determined by the independent demand inventory. So dependent demand inventory, you manage it using manufacturing resource planning systems, which take your parent item demand and divide it up into its different components and tell you how much is needed. Right. So that's what you see mainly in ERP systems, enterprise resource planning systems, and manufacturing resource planning systems. That's what those systems do, is they take your parent item demand and convert it into the dependent demand for all the parts that you're going to use. What we're going to focus on in this lesson is going to be your independent demand inventory. So it's the inventory of items that you sell to customers. It's the inventory that is coming from outside the organization. And this could be a B2B customer, so you could be selling parts to a car manufacturer, or you could be selling cars as a dealership to ultimate customers. You could be selling bread to many different stores, so it's a B2B relationship, or it could be a store that's selling bread to ultimate customers. So the independent demand item is going to be different based on where you are in that big supply chain. All right, before we get into the calculation of how much you should order, what I'd like you to do is think about the kind of things that you consider when you go out and get groceries. Take any one regular item that you purchase, and I say milk over here, for example. What are some of the considerations that you have when you decide how much quantity you're going to buy during this trip to the grocery store? Whether you're going to buy a gallon, 2 gallons, how much you're going to get from the grocery store. What are some of the things that go through your mind when making that particular decision? Right, so we're talking about going to the grocery store and getting milk. Some of the things that would have gone through your mind would have been things like how much do you have in your refrigerator, how much do you have at home, and how much do you consume on average. So your average demand rate of your household for that item, and here we said milk, but you could be thinking about any grocery item and how much you consume on a daily basis. The other thing that might go through your mind is how much does it cost from the perspective of if you have to think about the investment that you're going to make. It might not be much for milk, but if it's a more expensive item, you're thinking, should I be investing so much of my money in purchasing milk for future consumption? You might think about a price discount, and you might be tempted to buy more if there's a price discount available, or if you anticipate a price discount that's coming up, you might purchase less based on that upcoming price discount that you're expecting. Storage space is going to be a huge consideration, whether you have a spare refrigerator or you don't, and how much space do you have in your refrigerator for storing the milk that you're purchasing. Expiration date on the milk and how much you use versus when it's going to get spoiled is another thing that you might consider. And finally, you're going to think about when you're going to go to the store next. So if you're planning to not go for a couple of weeks and you're thinking, I need to get enough for a couple of weeks, and then there might be some uncertainty involved in how much you consume in that couple of weeks, so you might get a little bit extra based on what if guests come, or what if your family consumes more than they normally do in that particular period of time when you're planning to go to the store next. So these are the kind of things that you think about when you decide how much to purchase in terms of groceries for your household. Companies, organizations go through very similar decision making when they are deciding how much to purchase. So the kind of things that they're thinking about is how much capital investment there's going to be, how much storage space is going to be required, whether it's an item that's going to need handling, it's going to have to be stored in different places and moved around, whether there's going to be refrigeration needed, and if there's some kind of cost involved with that. They're also thinking about spoilage. So is there going to be something that expires over time? If it's something in which there might be a fluctuation in demand, it might get obsolete, so people might not want that particular product. So if you're thinking about a fashion goods store, you are concerned about the items going out of style and not being able to be sold, and that's when you would have to discount them. So those are the kind of things that companies are thinking about when they're thinking about how much inventory they want to purchase. So when you think about inventory decisions, inventory management decisions, there are two basic decisions that companies are making. One is how much to order, and the other one is when to order. When should they place the order? And these are going to be based on different considerations of the kind of things that we talked about a little bit earlier. Now, remember, we're focusing on independent demand items here, items that a company would purchase from a supplier that's coming from outside. And how much to order is typically based on this model that is very popular called the economic order quantity. So this is a model for calculating the amount of inventory in terms of how much you want to order. Now, this model is based on the principle of trading off two different costs. One of these costs is the cost of ordering. So if you think about the cost of ordering, if you're thinking about that trip to the grocery store, it's the cost of the time that you're spending to go to the grocery store. It's the cost of the gas that you might be consuming to get to that distant grocery store. For a company, it might be order processing costs. It might be cost of transportation. It's the cost of getting a truckload, and that might be a fixed cost, whether you get a full truckload or you get a quarter of a truckload. It might be a fixed cost based on that. So that would get counted under your ordering cost, right? So it's based on the number of orders that you have in a year. You're going to have an annual ordering cost from that. The other cost that companies are principally concerned about, and that gets incorporated into this economic order quantity model, is the cost of holding inventory. So if you think about the costs of finance that's being invested in this inventory, the insurance that you're paying on that warehouse, the opportunity cost of the space in your warehouse, all those things are figured into the holding cost for inventory. And when you think about the economic order quantity model, what you'll see is that it's trying to trade off these two different costs, right? And we'll see in terms of how it's trying to trade off these two different costs. Now, we are also going to talk about when to order, and we'll talk about that in a different lesson. In this lesson, we're going to focus on how much to order. But when to order is going to be based on a reorder point. So it's going to be based on when the inventory reaches a certain level. There's going to be a point that will be determined based on some analysis that we'll do that will say when it reaches a certain level of inventory, that's when you place an order. The question that we're trying to address here in this lesson is how much to order, and that's going to be your economic order quantity. So let's take a look at some of the things that get incorporated into this economic order quantity model. So the first thing that you want to get a perspective of is the trade-off between ordering and holding cost. So if you think about this from a perspective of annual quantity that's being ordered, if you order in smaller quantities, you are going to order many more times if you have the same annual quantity, right? You will order more frequently and you will have many more orders. So if you have a fixed ordering cost, your annual ordering cost will be very high because you've ordered many, many times. Now contrast this with the idea of ordering a large quantity at a time. So here in this extreme example, if this was the time of a year and you've ordered only 2 times in the year, you order 6 months worth in a year, your annual ordering cost is going to be based on just 2 orders. It's going to be very small. However, the cost of holding inventory, the cost of how much investment you have in that inventory, how much risk you're taking about that inventory getting obsolete or getting spoiled, is going to be much higher because you're buying 6 months worth at a time. So that's the idea of ordering cost and holding cost, and you can get some sense of a trade-off between these 2 costs, right? And that's what we're going to use in order to derive what is called the economic order quantity, in order to calculate what is called the economic order quantity. Now, the economic order quantity model is based on certain restrictive assumptions. It's a simple model, and whenever you have a simple model, it's probably going to have restrictive assumptions that are simplifying it in order to get the calculations done quickly. So what are the assumptions here? The assumptions are that the demand rate is known and it's constant. Annual demand is something that we know we can forecast very well. That's what we're assuming here, however unrealistic it may be. And we're also assuming that all demand is met, that you're never telling a customer don't have enough, all demand is being met. We're assuming a lead time of 0 at this point, right? When we get to reorder point, we'll talk about incorporating lead time in the reorder point, but for the economic order quantity, we're assuming a lead time of 0. So there's instantaneous replenishment. You place an order and you get the quantity delivered to you right on that day, right? So you're never worried about running short. The setup cost is fixed regardless of the quantity you order. So again, whether it's realistic or not, what we're saying is that every time you place an order, you incur a fixed cost. Whether that order is for a very small quantity or a very large quantity, the cost of ordering is going to be based on simply the fact that you placed an order. So it's a cost per order. The unit price is constant over the year, so over the period that you're calculating the economic order quantity, the unit price remains constant, and we're starting off with a model that does not involve discounts of any sort, so the unit price is constant in this case. So let's work towards coming up with the economic order quantity here. So we said it's a constant demand rate. On the x-axis you have time. On the y-axis, you have the quantity that's being ordered. So when you have a constant demand rate and an annual demand of D, your average inventory that you have at any point in time is going to be based on Q divided by 2. So if you're ordering Q at a time, your inventory is going to be based on Q divided by 2. Simply because you start off with Q, it goes down to 0. Starting and ending inventory are Q and 0, and the average is Q divided by 2. Right. So the next thing that you want to see is the time between orders is going to be determined by the quantity that you order every time you place an order, divide by the annual demand, or D. And if you take the opposite perspective of this, the number of orders in a year is going to be based on the annual demand divided by the quantity that you order every time you place an order. So simply stated, what this is saying is that if you have an annual demand of 10,000 units and you order 2,000 at a time, you're basically ordering 5 times in the year. So that's number of orders is 5 in a year, based on 10,000 being the annual demand and 2,000 being the order that you order every time you place an order. So that's reflecting, this picture is reflecting the assumption of there being instantaneous replenishment, there being a constant demand rate, and and we're keeping these assumptions in mind going forward. So before we get to the economic order quantity, let's take the perspective of ordering costs and holding costs as being the only two costs that we have, and calculate what would be the total annual cost of managing the inventory. So we're keeping the cost of the item aside. We're not taking that into account. We're simply looking at the total cost of managing the inventory. So when you look at the total cost of managing inventory, it's going to be based on two components. One of them is the ordering cost. So what you need is the number of orders, right? You need the number of orders in a year, and the number of orders in a year is going to be determined by the annual demand divided by the quantity that you order every time you place an order. And that's going to give you your annual cost of ordering. Now, on the other hand, you need your holding cost. Your holding cost is going to be determined by how much you hold at any point in time. So your average inventory, which is Q by 2, is going to determine your holding cost. So the ordering cost is going to come from the number of orders. So that's your one component. And the other main component is going to be the holding cost, and that is going to be determined by the average inventory that is held based on the fact that you're ordering Q at a time. So if you were to take those two components and try to come up with the total cost, you have the total number of orders in a year. You multiply that by the cost of ordering every time you place an order, and we call that S here because S stands for ordering cost or setup cost. Right? It could be setting up your machinery to make an item, in which case you're going to call it your setup cost. It could be the setup cost of your supplier, in which case you're going to use setup costs as the cost of ordering. And on the other side, you have the holding rate. So that's going to be like an interest rate. That's going to be calculated like an interest rate, but it's going to have some more components than simply the investment. It's going to have some component of how much percentage do you expect to be added for product to get spoiled, to get obsolete, and those sorts of things might go into a holding rate. So that would give you the total cost of holding inventory and ordering inventory, coming up with a total cost of inventory management. So if you take these two costs and you look at the trade-off between these two costs, that's what's being represented on this picture over here. On the x-axis, you have order quantity. As the order quantity goes from left to right, as it increases, so the more you order at a time, the holding cost, the straight line going from left to right in diagonal, is your holding cost. That increases the more you order at a time. At the same time, the costs of ordering or setup costs go down, and that's the curve that's going down from left to right, showing that the setup cost is going to be less if you order more at a time, simply because you have fewer orders. And the total cost curve, which is a combination of the holding cost and the setup cost, the total cost is the combination of those two, is giving you the total cost based on adding up both of these costs. So the optimal quantity Q star is what you want. It's the quantity at which your total cost is going to be at its absolute minimum. So there's going to be a unique minimum for this in terms of total cost, and that unique minimum of total cost is going to come from an optimal quantity Q star, which can be computed based on this economic order quantity formula. It's EOQ, or Q star, is the square root of your total demand, your annual demand, times your ordering cost, multiply that by 2, divide that by holding cost, and take the square root, and that gives you your EOQ. Once you have your EOQ given to you by Q star, your total annual cost using that EOQ can be calculated by the formula that you have on the bottom of the screen, square root of 2 times annual demand times setup cost for every time you place an order, times the holding rate that you have for your item. So that's the way you would be calculating your total annual cost if you were using EOQ. So to make the components of this formula clear, D is the annual requirement, S is the setup cost, and H is the holding cost. So you see that the EOQ formula, the formula for the optimal order quantity, it has a square root in it. And what are the implications of the square root in terms of what can happen when demand changes? So if you think about it, if the demand quadruples, if it becomes 4 times what it is, what will happen is it will result in doubling of the order quantity simply because the square root of 4 is 2, and it will also result in the doubling of the number of orders. It will double the order quantity, and the number of orders in the year would get doubled if the demand is quadrupled. On the other hand, the setup cost, which is also in the numerator of this formula, if the setup cost becomes a fourth of itself, the batch size is cut to half. So this gives you an idea of if you want to reduce the batch size to a half, you need to reduce the setup cost, which is where a lot of companies put their attention in terms of reducing ordering costs, reducing setup costs. If you can reduce that to a fourth of its original, then the batch size is cut to half. The other thing about the EOQ is that you can see that the total cost curve is pretty flat at the optimal point. At the point at which the total cost is at its minimum at Q star, the total cost curve is pretty flat. What do we mean by that? If you move to the left or if you move to the right of Q star, even by a substantial amount, the annual cost doesn't go much higher than the lowest cost by too much. So it's robust to any misestimations that might result in getting an incorrect Q star. So if you were to misestimate the holding cost or the setup cost, which results in a misestimation of the optimal order quantity, you would have to misestimate it by quite a bit for the annual cost to be substantially higher than what would have been based on the optimal order quantity. All right, now let's take all that we have learned in terms of the EOQ and apply that to see the mechanics of how you would calculate the EOQ for a particular company. So let's practice this calculation based on this problem that we have here. Annual demand 10,000 units, cost to place an order $10. Every time you place an order, you incur a cost of $10. Holding cost is 30% of cost per unit. Obviously, this includes more than the interest of investment, interest on investment that you have in inventory. So it's got a little bit more than that. That's why it's at 30%. The cost per unit is $15. So what we're going to do here is determine the economic order quantity, and then we'll go back and check the annual holding cost and the annual setup cost, and we'll see what we can find there. And then you can also check, based on the formula that we saw earlier, the total cost, even without calculating the holding and setup costs separately. So take a minute and work through these calculations, and then we'll come back and see if we can match what you found with what we'll be doing here. All right, so let's first do the calculation of the EOQ here. So the EOQ here is going to be determined by that formula that we looked at earlier. So it's 2 times the annual demand, which in this case is 10,000 units. The ordering cost or the setup cost is $10. So this is in units. The 10 is in dollars. So it's $10 here. And then we have 30% holding rate. So that's a percentage, and you're multiplying that by the cost per unit, which is $15. And that gives us an EOQ calculated exactly. That works out to 210.8. So you would round it up. And since we know that EOQ is robust to a little bit of misestimation to the left or right, we're going to call it 211. Right. This also tells you that if the packaging size is approximately close to 210, that would be okay. That you could order 200 at a time if that's the packaging size, if that's what's convenient, and you would still be very close to getting the best total annual cost. Now let's go to the components of calculating the total annual cost. for ordering and the total annual cost for holding. So total annual cost for ordering, number of orders is going to be based on the annual demand. So that's 10,000 units of annual demand. You order 211 at a time. This will give you the number of orders. And let's separate this over here. And on the basis of this number of orders and multiplying it with the cost to place an order of $10, you can work out the annual cost of ordering for this quantity. For holding costs, you would take the Q, which is 211. You would divide that by 2 to get an average. So here we're talking about holding costs. And this is annual holding cost. 211 divided by 2 is the average inventory. You multiply that with 0.3. And you multiply that with the $15 of the cost of the item. And that should give you the annual holding cost. So if you were to work through these numbers, what you would find is that the total cost works out to $948 and change. And what you would notice from looking at the calculations for the cost of holding and cost of ordering is that they approximately equal each other. So you have $474.75 for the cost of holding, and you have $473.93 for the cost of ordering. And of course, this is not by accident, because the economic order quantity that we calculated is based on trading off these two costs. So it's the point at which the total cost of ordering for the year and the total cost of ordering of holding for the year are equal to each other. So that's what we found. Now you could use the formula that we looked at earlier for total cost and check your work in terms of finding out what the total cost would be, and you would find that it would be exactly the same. Okay. So here we have the EOQ being used to calculate how much to order. The other part of the decision for inventory management is going to be when to order, and that's going to be based on calculating a reorder point, and that's what we'll look at next.